Welcome back, everybody. We are ready for another set of notes in Unit 3, so go ahead and flip to your Unit 3 table of contents. Looks like we are ready for page 31. And on 31, we're going to be talking about graphing absolute value functions. So, graphing absolute value functions. Graphing absolute value functions. And as always, once you get done writing that down, you were giving the notes either from me in class or maybe you printed them off from Google Classroom, but here they are. You're just going to take this, fold it in half, and then tape it down onto page 31. So go ahead and get that done now, and then push play when you're done. That should be taped in, so we are going to go ahead and start talking about graphing them and the steps on how we would do that. But before we get there, we need to talk about the general form of an absolute value equation. The form of it is called vertex form, and it looks similar to this. Now, we've seen equations that look like this all the time. We've solved stuff that looks like that, and we've talked about the key features of stuff that looks like this. So this is actually in vertex form, and these letters are the spots where you would see numbers. So we need to talk about these letters and the specifics of how they affect the graph. So we're going to start with this A, because we have f of x is equal to A. This A is the steepness of the line. So that's going to tell you how steep the side of the absolute value graph is. We can call this slope. It's basically slope. We have to do the mirror image of it because of the absolute value graph looking like a V, but I'm going to explain that in just a minute. So it's the steepness of our line, and that's called slope. Okay? The next two that I want to talk about, and we're going to do them together, is this H and this K. These two together make your vertex. HK is the vertex. So we can actually get the vertex without even looking at the graph. All we would need is the equation. There is one weird thing that we have to do with the H value right here. So I want you to put a star because it's super important. We need to take the opposite sign of H. So HK, again, is going to make up our vertex. We're just going to pull these two numbers out, and there's going to be our vertex. But whenever we write our vertex, we have to take the opposite sign of H to make it work correctly. So that's the background knowledge that we need to know about vertex form before we can actually graph them. So now that we have that down, let's look at example number 1. We are only going to focus on graphing it in this middle section. And then down there at the bottom, I've got the key features that we learned last class. So for example 1 right here, here's our equation. We have f of x is equal to the absolute value of x plus 2 minus 3. So here are the steps. They're in a little bit smaller writing, but we're going to go through these steps and graph this at the same time. The process that we're going to take to actually graph this is the same every single time. So, step 1, we need to identify and plot your vertex. So, the two numbers that make up the vertex, I talked about it up there, is this number and this one. That's what makes up my vertex. So my vertex, this is HK. I need to take the opposite sign of H. So I'm going to have -2. K is going to stay the same. So that's going to be a -3. And there's my vertex. So that's how we pick out the vertex without even looking at the graph. Well, now that I know what the vertex is, I need to go plot that point on my graph. So remember, ordered pairs are always x, then y. So from the origin, I'm going to go to -2 and then down to -3 and plot me a point. So there's the first part of our graph, and this is the vertex. So this is the middle of the V that we're about to graph. Okay, step 2. Starting at the vertex, use the A value. That was the number in front of our absolute value. Use the A value to plot more points on the right side of our vertex. So I want you to underline the right side. Super important that you do the right side first. A acts like our slope, which we've kind of already talked about this. So A functions as our slope. So let's go back to our equation to talk about our slope for this one. A would be right here in front of that absolute value. We don't technically see a number there, but there is an understood 1 right in front of that. So that means we have a slope of 1 over 1. So from this point that we've already graphed, remember, we're doing the right-hand side. So from the graph, we're going to be going this way. We're going to go up 1, right 1, up 1, right 1. And I normally get 2 or 3 points, and then I'll be done. Okay, so that gives me the right-hand side. Step 3, it says go back to the vertex and draw the lines draw the mirror image. So mirror image of the line on the left side of the vertex. Because here's the thing. If we were to stop right here, this looks like a linear function because it's just a straight line, but we know that we're dealing with an absolute value graph, so it has to look like a V. This is one side of the V. I need to go back and get this side of the V now. So if from my vertex I went up 1, right 1, the mirror image would be up 1, left 1. So I just need to make sure that these dots are exactly across from each other and that my final product looks like a V. So I got enough points. I can draw me a line. So now I didn't put it in for step 4, but you would take your protractor or a straight edge and actually make the lines to create that graph. So you just line it up. I always start at my vertex and I draw a line. Arrows need to be at the end because these do continue on forever. Just like that. And there we go. So graphing these is not difficult. We've been shown new letters and we need to understand how they affect the graph and what they can do for us. Okay? So before we move on and start practicing some more graphing, I want to talk about the key features. This is what we learned last class. So these are our key features down here. So we're going to talk about the vertex. We've actually already graphed the vertex and we've graphed our whole graph. We actually labeled out what our vertex is up here. So we're just going to bring that information down. So -2, -3. Now, direction of opening focuses on these arrows. Since the arrows are pointing up, that means that the graph itself opened up. This vertex is going to be a minimum value because this is at the bottom of the V. So remember, a couple years ago, I had a student that when he saw this, he told me that it reminded him of a bowl, and this was the bottom of the bowl. It doesn't matter how you remember it. You just need to remember that if the graph opens up, this is a minimum value. Axis of symmetry, remember, is I'll draw it lightly. Axis of symmetry is the vertical line that would cut that graph directly in half. Symmetry means same on both sides. So that number is -2. So the equation of that line is x equals -2. And remember, the pattern that I tried to show you in class was that these two are the exact same because the vertex is sitting on the axis of symmetry. Zeros are where does the graph cross the x-axis? It does it in 2 different spots. If it asks how many zeros, you would just tell me 2, but it doesn't specify, so we're assuming they want to know what are the zeros. So we have -5 and +1 because it crosses the x-axis at -5 and +1. The only thing left is domain and range. So we have the domain are the x values, so that's left and right. So when we look at this graph, it's going to continue forever left and right. Now granted, it's going to go up, but it's also going left and right on both ends. And that's going to cover every single number that's on the x-axis. So that is the double barred R, the all real numbers, which I'll write that as well. All real numbers. Our range values, they're not ever going to be all real numbers for absolute values, so we really got to pay attention to where the graph starts. So the range values start right here at -3. That's the lowest that it goes. So knowing that, this is how I set my range stuff up. I'm going to have y is something -3. And then the only thing that I have to come up with is is it going to be greater than or less than part. And that deals with, does the graph go up? Does it open up or does it open down? Since this one opens up, it's going to be a greater than or equal to. Because what that is essentially saying is that every number -3 and up or greater, we are going to use to make this graph. We don't use anything down here, so we can't say less than. Okay? Okay, so now let's flip to the inside. And I actually want to look at example number 3 with you guys. So we're going to do example 3 together, and then I'm going to have you backtrack and do example 2. So we're going to talk through the process, those steps that we would take in order to graph our equation. Number 3 is a little bit harder problem, so that's why I wanted to do it together. So the first thing that we always need to find is our vertex. And so our vertex, remember, is HK. H is on the inside, K is on the outside. So I'm going to rewrite this in a way that we can actually see the H value, because there's nothing in there with that X. And since there's nothing in there, that means that it was a +0. Because if there's nothing in there, then we didn't have to write it, so it was a +0. So this is actually our equation. So my vertex is going to be 0 and 2, because I'm going to take out that 0 and I'm going to take out that 2. The 2 is going to stay the same. We technically changed the sign of the number on the inside, but it's just 0, so it doesn't really have any other sign. So let's go ahead and write that. It's going to be 0, 2. And now we can actually plot that on the graph. So 0, 2 is going to be right there. Make that a little bigger. 0, 2. The next thing was I needed to use the A value, which is right here, to come up with more points. So remember, this acts as our slope. So we're actually going to use that to come up and plot more points. So it is a negative, so remember that goes with the numerator. So we're going to, from this point, and remember we're only doing the right side of the V. So this one's going to be an upside down V because of that negative. So from this vertex, we're going to go down 1, right 2. Plot a point. Down 1, right 2. Usually 3 points are okay, so if you can get 3 points, then you're good. So there are my 3. So that's one side of my absolute value graph. Now I need to go back and do the other side. So I go back to the vertex and I just do the mirror image of this. So if this one was down and right 2, I need to go down and left 2. And then down 1, left 2. So when you're finished graphing, you need to keep this in mind. This is symmetric. So if I wanted to fold this on this line right here in the middle, that these dots would line up. That's what it is to be the mirror image. Once you get about 5 points put on your graph, you're just going to take your protractor, your straight edge, whatever you've got, and we're going to actually finish drawing that graph. Make sure that you have arrows on the end because these do continue on forever. And there we go. So that is graphed completely. And now I can answer the rest of these key features questions. So first thing, we have our vertex. We found that from our equation, and then I used it to actually come up with my graph. This vertex is a maximum because this is like a little mountain. Remember I said if it opens upside down, then it's a mountain and you're standing on top of the mountain. So the direction of opening is going to be down for this one because these arrows are facing down. Axis of symmetry, well, sorry, let's go ahead and get those zeros first. So zeros, remember, is where does the graph cross the x-axis? It does it in two spots, right here and right here. We just need to list out those numbers. So we have -4 and +4. Easy as that. Now let's backtrack to get axis of symmetry. Remember, symmetry means that we can cut something in half and it's going to be the same on both sides. So if I cut this graph in half, I'm going to end up cutting it right here because that's the halfway spot and I can fold it and it's going to be perfect and symmetric. That number is 0, so it's going to be x equals 0. Okay, then we have domain and range. So domain is left and right. These two lines continue on forever, left and right. So that's going to be all real numbers. All real numbers. And if you want to, remember that you could just use that symbol that stands for all real numbers. That's totally fine. Our range is a little bit different. We have to figure out where the graph starts, which this graph starts here at +2, and we're going to use everything below +2 because our graph goes down. So my range for this one is going to be y is less than or equal to +2. Okay, now that we have finished up with example number 3, I want you to backtrack and do example number 2. The only thing that I want you to kind of keep in mind is this number in that A value spot is a whole number. So any whole number, we can put it over 1. So whenever you go to graph the points for the right side of this absolute value graph, just be sure you're graphing the correct slope, okay? So go ahead and get that done, and then when you are finished, go ahead and push play, and I will show you the correct answers. Okay, and here is example number 2. So our vertex, I put at 3, 1, because I'm going to take these two numbers, change the sign of the first one. So I plotted my vertex, and then I'm going to use this number out in the front in the A value spot to plot the right side of my absolute value graph. So I'm going to go up 2, right 1, up 2, right 1. Then I need to get the mirror image, so I graphed the left side and then actually drew the V. So the vertex is a minimum. Axis of symmetry, that's one of the ones I want to talk about. I put it at 3 because if I'm going to talk about the line that cuts this graph in half, it's this one, and that line is x equals 3. There are no zeros, so I just put none. Domain is all real numbers because it goes forever left and right. Range is, I put y is greater than or equal to 1 because here's the starting point of my graph. It's here at 1, and I put greater than because the graph is everything greater than 1. So 2, 3, 4, all of those numbers are bigger than 1. There you go. Now, stuff on the right. Let's talk about these problems. I'm only going to do one for you, and then I'm going to let you practice the other two just to get some extra practice in. The instructions say, write an equation for each absolute value function whose graph is shown. State the vertex and domain and range. So we are going to take a look at number 2. I'm going to kind of work you through number 2, and then I want you to try 1 and 3 on your own. So what I want you to see is we're working backwards from the first 3 examples that we did. The first 3 we were given the equation and then had to come up with the graph and then all the information. This time we are given the graph and going to come up with the equation and all the other information. So take a look at example number 2 for me. Zoom in a little bit. So example number 2, we have the graph. We are trying to come up with the equation. Now, if we look back, the 2 things that we need for the equation is the slope and our vertex. So we're going to label out what those two things are, and then we'll be able to build our equation from there. So our vertex, okay, I'm just going to go ahead and put it in the vertex spot because we have to identify that anyways. The middle point of our graph, or the V, is the vertex. So this is going to be -2, -4. So this is -2, -4. So we're going to use that in order to create our equation. But we also need slope. So when you are trying to determine what the slope is, you need to make sure that you only look at the right side of our graph. So when I do that, this slope right here is up to right 1. So that is 2/1, which we can just write as 2. This is going to be our A value. So now let's just build the equation. And I want you to remember that the equation is f of x is equal to A, absolute value, x minus h, plus k. This is what we're trying to build, but with the information here and here. So we're going to start with f of x is equal to, the value of A is the slope value that we found over here, so I'm just going to plug in a 2 for that. My absolute value, we don't plug in anything for x because HK is my vertex, so I'm going to bring those numbers up there down. So x, here's the thing. The h value, we change the sign of, because here's what actually happens. It's going to be a minus, and then we're going to plug in a -2. And a minus negative makes a positive. So this is actually going to be a +2, because remember, we're changing the sign. So if it's negative right here, when we put it back into the equation, it's going to be positive. And then that k is just going to be whatever number that is. So -4. And there you go. There's the equation. So that's how we work backwards from the graph to get back to the equation. We would need two things: the slope of the right side and our vertex. And that'll be it for us. Now, we need domain and range, because remember, that is a very serious topic that whenever you get to Algebra 2, those teachers are going to expect that you know what those are. So the domain are x values. These two arrows and lines are going to continue forever left and forever right. So that's going to be all real numbers. All real numbers. Our range is the one that is going to be different. We have to figure out, where does the range start, or where does our graph start, which this one starts down here at -4. So I have y is something, -4, and I have to decide what inequality goes there. And this time, we're going to use a greater than or equal to, because this graph opens up and it's above that little yellow line that I just drew. And there you go. That easy. So what I want you to do now, I want you to take a little bit of time and try graphs 1 and 3 just to see if you can come up with the equation. Use number 2 as a guide to kind of help you. Main thing though, just remember, we need our vertex, duh, but we also need the slope of the right side of our graph. So go ahead, pause this video, get 1 and 3 done, and then push play when you're done. As promised, I'm going to show you numbers 1 and 3 just to make sure that you have the correct answers in your notes. So, number 1, vertex at 3, -2. The only thing that you needed to be careful with number 1 was the slope part. So, remember, it's only the right-hand side. We're going to go down 1, right 1. So, the fraction is -1/1. But when we look at the equation, and I wrote it the way that you will normally see it. You will normally not see a number 1 in between that negative and that absolute value bar. So you're just going to have to understand that there is an imaginary 1 there. Everybody knows that there is a 1 right there. Domain is all real numbers. Then the range is y is less than or equal to -2, because the graph starts there at -2, and then we use everything below that graph. Okay, and number 3 is right there. 3, 1 was my vertex. And so the slope on this one was a fraction, which is okay. we just went up 1, right 2, so that gives me a 1/2 as a fraction. So I just put the 1/2 out there in the front, and then I did my vertex in my equation. But remember, the h value needs to change. So whatever it is up here, just do the opposite when you build the equation. Domain is all real numbers. Range is y is greater than or equal to 1, because there's the bottom of my graph at 1, and the graph opens up. So I'm going to use everything above there. Okay, you guys did awesome today, and I'll see you next time.